Hey all, so this is the video for Chapter 1, Section 1, and it's going to be a bit different than, all of the other videos I make for all the other lessons and all the other sections. This one is going to be a run-through of the online resources, the online materials that you have available to you, and it's just another extra, remediation kind of thing, or just extra instruction, even a little bit interactive that you can do for every section, every lesson. And this is also exactly where you're going to go, probably almost like every day. If you are just getting your homework problems, from the e-text, from the online textbook, rather than lugging around your textbook. So this is obviously, as you can see here, pearsonrealized.com, and you log in with the username and password that I provided to you in class. And quick side note about that, it seems like the capitalization on the username doesn't matter, but it looks like capitalization on the password does matter. But so once you log in, you're obviously going to go to like the Algebra 2 program, and Chapter 1, because we're looking at patterns and expressions from Lesson 1-1, and here they give you the e-text, and this is what you're going to click to find your homework problem so you can do your homework. But the interactive learning and the guided instruction is all. So we're going to run through this, kind of like I'm going to run through in class, like let's say you miss class. So step 1, the interactive learning. So you just click, and it's just going to stay like this. So you would click down here to move on to the next screen to begin. And then it kind of gives you again, a somewhat interactive, warm-up problem or beginner problem. And you can kind of keep on hitting play as needed. So you're playing a video game, you reach a locked gate. The lock is a square with 9 sections. See, 1, 2, 3, 4, 5, 7, 8, 9. You can make a key by placing a red or yellow block in each section. Near the gate is a carving of a pattern of squares. The key to the gate is the 8th image in the pattern. Draw the key to the gate. How do you know it will work? Well, so basically, if you basically just kind of boil down to what it asks, what it wants, you want to figure out what the pattern here is, because here's the first key, right? Or the first image. This is the second image. This is the third image, and you got to find the pattern. And we're just looking for the 8th image. So looking at this, you should look at this and try to figure out on your own before hitting play, what do you think what the pattern is, and basically how you would sort of get your way to the 8th image. So do we see a pattern here? And as I hit play, why is the middle square always yellow? Then if you still can't figure it, well, here we go. Each figure in the pattern is created by rotating the previous figure 90 degrees clockwise, like you just saw. Since the middle square is yellow in the first figure, it'll be yellow in all the figures. And then you have the option of clicking on the solution, like I just did there at the bottom. And again, we're looking for the 8th image. So then this is done, and it's fairly easy to navigate. Looks like we have to X out of here. And then once you're done with this whole, part of the lesson, right? See, like down here, I guess we could go back or whatever, but you would want to go up here to exit, so you can get back to this screen and then move on to, so we did this solve it, this interactive learning. Now we can move on to step 2. And it looks like here's the key concept or key concepts. Essential understanding, you can represent some patterns using diagrams, words, numbers, or algebraic expressions. So again, it's really about patterns. And here's some things we can use to represent patterns. A variable, this should not be a new word. Symbol, usually a letter that represents one or more numbers. So here's a couple examples of variables. A numerical expression is a mathematical phrase that contains numbers and operation symbols. So there's an example of a numerical expression. Here's another example of a numerical expression. Again, like these wouldn't include any variables, just numbers and operations like plus, minus, multiply, and divide. But an algebra expression is a mathematical phrase that contains one or more variables, like this one or this one. And look down here. Just one of one, so I don't think that doesn't do anything. You gotta exit out of here, and then the next thing would be this problem 1. So now they're doing some examples.
In this problem, you will identify a pattern. Look at the figures from left to right. What is the pattern? What would the next figure in the pattern look like?
And then when you're ready,
how can you identify a pattern? Look for the same type of change between consecutive figures. The triangle has 3 sides. The square has 4 sides. The pentagon has 5 sides.
hexagon.
And the hexagon has 6 sides. The pattern shows regular polygons with the number of sides increasing by 1. The last figure shown above has 6 sides, so the next figure would have 7 sides, a heptagon.
And if you didn't notice, I had to keep hitting play. It would stop itself, and then whenever you're ready, you can hit play to move on. So I had to hit play like, 6 times or something. And then if you notice down here, this is 1 of 2, so once you are ready, you can move on to this one. And I guess this one is, you really get to try this on your own, and here we go. Look at the figures from left to right. What is the pattern? Draw the next figure in the pattern. Well, it just looks like, it's a cross or a plus sign, and it looks like it's just increasing by 1 in all 4 directions, to the right, left, down, up. So 2 squares and then 3. So then the next one would be a red square in the middle, but with 4, squares coming off of those 4. So answer choices. So you get some choices. Just a couple, I guess. And again, just going off of especially like the red squares here, it doesn't seem like it's always one red. I mean, I don't need to explain that. You can see it's not A. Patterns. It's obviously B. And should speak for itself, I guess. Like, no explanation here that they give you, and I don't see one as needed here. You just got to see the pattern and keep it going. And so again, like now you have to exit out of here completely. And I believe we're now on problem 2.
In this problem, you will express a pattern using algebra. Use the pattern to answer each question. Part A. How many toothpicks are in the 20th figure?
So this is figure 1, this is figure 2, this is figure 3. So there's 4 toothpicks here. Looks like there's 8 toothpicks here, 12 toothpicks here, and you should be able to see a pattern and be able to take that all the way, maybe even like do some skipping. You know, like do you really have to draw all 20 figures, or you know, these are the first 3 are already drawn for you, but do you really need to draw all the other figures all the way up to the 20th figure, or can you find a pattern that lets you just skip to like the final answer? You know, 4 toothpicks is the first figure, 8 toothpicks is the second figure, 12 toothpicks is the third figure, and then, you know, there's a pattern you can find there. Let's see how this goes.
You can use a table to look for a pattern relating the figure number to the number of toothpicks. Figure 1 has 1 times 4, or 4 toothpicks.
And obviously next they're going to probably do what, you know, figure 2, and what would go here in like what they're calling a process column. And then that of course leads to like the actual final number of toothpicks, which we know is supposed to be 8, right? But how does that happen? And the picture helps. You know, looking at the picture, how there's like 2 different squares of 4 toothpicks each.
Figure 2 has 2 times 4, or 8 toothpicks.
This is intense.
And figure 3 has 3 times 4, or 12 toothpicks.
And then now can we see a pattern, like especially here, that lets us skip ahead to figure number 20?
To get the output in the table, multiply the input by 4. So the pattern is you multiply the figure number by 4 to get the number of toothpicks. So there are 20 times 4, or 80 toothpicks in the 20th figure. Part B. What expression describes the number of toothpicks in the nth figure?
Okay, so what if we wanted an expression that described how many toothpicks were in figure number n, where you know, n is open to be anything. You know, it's like open-ended, right? So you're not going to have a very, very, very specific final answer. You know, it's going to be, you know, the number of toothpicks is based on whatever you're going to be plugging in for n. So, but the thing is, you're going to be treating
Use the pattern from part A.
Treating n as a number.
What would the process column for the nth row look like?
So since it's always the figure number times 4, you know, 1 times 4, 2 times 4, 3 times 4, we're just going to do the same, but it's just going to be n times 4, you know, like whatever times 4, because n could be whatever. So this is going to be basically 4n.
The expression is formed by multiplying the figure number n by 4. So there are 4 times n toothpicks in the nth figure.
And remember, like 4n, like what's 4n? Well, it depends on n. And n could be, it's the nth figure. It's whatever figure you want. So in a way, 4n represents the number of toothpicks in any figure. It just depends on what n is, like the figure number. And this one looks like it's done, but down here in the lower right, it seems that there's one of two. So here's the second one. And again, we can try this one on our own. How many tiles are in the 25th figure? How many tiles? So it's interesting that they make a red one. They didn't say how many. This is just how I'm reacting to these pictures. I'm looking back at the directions. It doesn't say how many yellow tiles or how many red. It just says how many tiles. So both yellow and red together, I guess. It just says how many tiles. Or in the 25th figure, use a table of values with a process column. So it looks like it's going to be the figure number 1 is going to be 4. Figure number 2 has 6. Figure number 3 has 8. So it looks like it goes 4, 6, 8. In the next figure, it looks like there's going to be 10. So, there's your choices. So the 25th figure, it looks like it's all, it's best if we do this on paper, which I can't do here, but just kind of like saying this out loud, like verbally, right, inside my head at the same time. Looks like it's always the figure number multiplied by 2 plus 2, So it looks like there's always like 2, right? Like how can I explain this? Like you're always adding 2 more, based on the figure. So, it's like in figure number 1, it's like we were adding, like we had added these 2 to like an original 2. So it's like you're always doing 2 plus 2 times the figure number, right? 2 times the figure number is 2 here. 2 times the figure number here gets you adding 4 to the original 2. Here it's like you're taking the original 2 and you're adding 3 to, so like what's 2 plus 25 times 2? So I think the answer is going to be B. And I don't know why they're not including like a whole table of values with this, but so the correct answer is 52, right? So let's take a look at the solution. There it is. My bad. So again, yeah. Remember, you guys can't see this on this video, but I'm standing in front of the projector, and the shadow of my head is literally blocking this solution, link from me, this button down here. So yeah, don't forget there is a solution, click down here. And yeah, so this is what I was saying, right? And it's always like you're doing, it's like I said this first, 2 plus, 2 times whatever the figure number is. So figure number 1, figure number 2, figure number 3, and that's kind of some math, using the figure number always to get the total number of tiles. And so here we go. And now we can exit out of here. And I believe we're now on problem 3. Oop, I knew I clicked on info there, separate link. Well, let's take a quick look at that, actually. Here's some info, apparently. Oh, these are just standards. You probably don't care about this. Keywords. What's this info? Standards. Yeah, maybe you don't. Maybe this is not worth. Yeah, you don't. I don't think this is very important too. So we did problem 2, I believe, right? And now we're on problem 3.
In this problem, you will use a graph.
An aquarium.
You want to set up an aquarium and need to determine what size tank to buy. The graph shows tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish it can hold. If you want 5 2-inch platies, 4 1-inch guppies, and a 3-inch loach, which is the smallest capacity tank you can buy? 15-gallon, 20-gallon, or 25-gallon? Use the table to find the answer.
Okay. So remember, down here is the combined lengths of the fish in your tank, in your aquarium. And then up here is the capacity that you would need for each combined length. So for example, this is interesting how it starts, but for 0 inches of fish total, you still need a 2-gallon tank. But for 2 inches of combined length, we need 4 gallons. Then if you had 4 combined inches of fish, you would need 6 gallons in your tank. 6 inches of fish means 8, and so on and so forth. So here's the hypothetical, like what if we have 5 2-inch okay, so that's 10 inches total, plus another 4 inches because 4 of these 1-inch guppies, so that's another 4 inches. That makes now 14 inches total. And a 3-inch loach, that brings us up to 17, I believe. Again, it's not recommended to do all this in your head all the time, write this stuff down, right? But anyway, I should let this video do its thing.
Calculate the combined fish length.
I just can't help myself. I was right.
The combined fish length is 17 inches. How can you use the given graph?
Okay. Yeah, so the graph gives us a pattern, it's almost like you could say this is the left column of a table, and these numbers would go in the right column of the table, where 2 correlates with 4, 4 correlates with 6. Actually, I should probably not just go 2, 4, 6, 8. I should probably go 1, 2, 3, 4. So, as the left column goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the other column can go 3, 4, 5, 6, 7, 8. Okay, anyway, again, I'll just let the video do its thing.
You can use the graph to make a table and find a pattern relating capacity and combined fish length.
Think.
Choose some points on the graph. Choose points that have whole number coordinates, such as 0, 2, 5, 7, and 10, 12. Make a table using the input and output values shown in the ordered pairs. The input values represent the combined fish length. The output values represent tank capacity. Use the process column in the table to find the pattern. 0 plus 2 equals 2. 5 plus 2 equals 7. 10 plus 2 equals 12. So each output is 2 more than the corresponding input.
Right, so not to just blatantly repeat what she just said, but so it looks like the capacity will always be 2 more in gallons. The number of gallons will always be 2 more than the combined inches. So you always take, whatever the inches are and just add 2 to that number, whatever it is, to get the gallons.
You want 5 platies, 4 guppies, and 1 loach. So you will have a total of 17 inches of fish. Find the output when the input is 17. The output equals 19. Now write the answer in words. The smallest tank that has a capacity greater than 19 gallons is the 20-gallon tank. So you need to buy the 20-gallon tank.
Yeah, sort of just, I guess you got to make sure you're ending this problem the right way. You got to think back to what the original question was. And, so the final answer is not that, you would need a 19-gallon tank. It's which one of these tanks would fit that, is like the smallest capacity tank you can buy. So yeah, I mean, the final answer is the 20-gallon tank up here, huh? So that's that's problem 1 of 2, and we can move on to now, I guess, trying one yourself. The graph shows the total cost of platies at the aquarium shop. How much do 6 platies cost? Use a table. It looks like 0 platies cost $0, obviously. 1 platy would cost $2. 2 platies cost $4. 3 platies cost $6. So, you should always, for these ones, and just in my videos in general, feel free to pause the video and try examples on your own before just getting, the answer for free, as a spoiler. So they want 6 platies. I mean, 6 is just right here. It might have been, a little bit better of a question to ask about maybe like 10 platies or even like 30 platies or something. Something that would be like way out of bounds, and you pretty much can't just use the picture, and do it graphically. But anyway, it does seem like in the pattern, and again, pause the video if you want to try this on your own, but looks like the pattern is you're just taking the number, and this would show up in your table, that you're just taking the number of platies and multiplying that number by 2 to get the total cost. So 6 platies, you multiply that number 6 by 2, and it should cost $12. So I'm going with D here, if it was multiple choice, and the correct answer is 12. Let's see what the solution. Yeah, okay, they're not going to talk, are they? So, okay, here's the table that you could have theoretically drawn. So you're always just taking the input, which is the number of platies you're buying, and whatever that is, 0, 1, 2, 3, 0 platies, 1 platy, 2 platy, 3 platies. You're just always multiplying it by 2. So you take that all the way down to 0, 1, 2, 3, 4, 5, 6. 6 times 2 is 12. So now we exit out of there. And they also have this lesson check and step 4 practice. So, well, here's just your textbook, I believe, right? let's see here. What? Pearson e-text applications. Wow, this is interesting. Hey, maybe you're running into this problem too. This is kind of embarrassing. What is going on here, man? Do I have to not secure? Oh boy. Woo. Well, hey. Hopefully you caught that. Just go back on the video, but I guess that might be something you have to do. I don't know. You guys have your Chromebooks. At least it's 2019, so which in these days if you're a student now, you have a Chromebook. So I don't know if that's going to happen to you, but yeah, it looks like this is just where you're going to find your homework. So let's go back and see what this virtual nerd tutorial thing. What are numerical and algebraic expressions? I think this is referring back to the key concept. So let's take a look at what this is. Open in a new window. Ooh, this is interesting. So it's down here, notes, keywords. So it's a video. Algebraic expression, is this just part of the video? Ooh, I can click on this. Four and a half minutes.
So let's look a little bit at numerical and algebraic expressions. First, we'll look at numerical expressions. A numerical expression is a mathematical expression that contains numbers and operations. Remember, operations are things like addition, subtraction, multiplication, and division. So, if you have an expression that has nothing...
So I don't think we need to watch all of that. I mean, you can if you need to, just kind of log on and do it, but this is also something that you have available to you with a note down here and some keywords that could be important. Looks like you can, by clicking over here, you can jump ahead, jump around in the video, I guess. But so you can just exit out of there. And yeah, so again, you'll have homework, which you can find, I guess, here or up here. Student e-text lesson 1. Or actually, just one more final thing. This might be this is maybe the entire section 1.1 with all the reading included. So this one starts here, but if you just click on the bottom one here, that'll jump just to the practice exercises. But it's all the same. But even here, I can jump back earlier in the notes, right? So it's all the same thing. And so good luck on your homework. And that does it for section 1.1, patterns and stuff.